Basics of electrical engineering. Electrical engineering have lot of subjects like electromagnetic theory, digital electronics, power system, power quality, control system, electrical machines, many subjects. In that, we have taken about the power system basics. And power system is having topics like generating station, transmission, distribution, feeder lines. In that we have taken transmission. So very basic about transmissions. So what are the topics we are going to cover is the relation between the cable length and capacitance. How do we relate the length of the cable and the capacitance which is present inside the cable? So that what is the relation? The relation between cable length and resistance. Relation between power and voltage in the transmission line. What will happen if you increase the voltage? The power will be increased, or what is going to happen? Those relations can be seen. Next, what is voltage regulation? What is corona effect? What is skin effect? What is Ferrara effect? What is transpose in transmission line? All are very basics about the transmission. So the first topic is the relation between the length of the cable and the capacitance. So we can see the diagram of the cable, how the cable structure is. There will be a center core. The core will be a conductor. And after that, we have a dielectric insulator. Then we have a metallic shield. The outer cover is plastic. So this is the structure of a cable. The cable should be installed in many different places. The cable should withstand with different temperature. It can be a very cold temperature or a hot temperature. It should not melt or it should not crack. It should sustain with a different current rating. So according to that specifications, the cables are designed. And to give mechanical strength also, to give mechanical strength. So these are the specifications we keep to design the cable. And when we see the first point, transmission line conductor constitute a capacitor between them. So naturally, what is the capacitor is? Capacitor will consist of two plates, and inside that a dielectric medium will be there, and it will be charging the voltage. The same thing is happening in the cable line. So the conductor will act like a parallel plate, and the air is like a dielectric medium, and it will get charged. So this is what happening in the cable. The conductor will act like a parallel plate of the capacitor, and the air is a dielectric medium between them. So this will also charge. So the current, the capacitance of the line gives rise to a leading current between the conductors. So this is going to give leading current between the conductor because it is charging. So that also depends upon the length of the conductor. So what is the relation now? It depends upon the length of the conductor. So what is the relation now? Relation between the length and the capacitance is, length is directly proportional to the capacitance. So here the capacitance is measured in picofarad by foot. So what is the meaning of this is, this indicates how much electrical energy the cable can store. That is picofarad by foot. So the actual formula is C by L is equal to 2 pi epsilon natural log of capital R by small r. The capital R is outer radius and small r is inner radius. What we get from this equation is C is proportional to L. So when the length of the transmission line is increased, the capacitance is also increased. That's what we want from this slide. When the length is increased, the capacitance is increased. When it is a short line or a medium line, there will not be much capacitance in that line. We will not get the receiving voltage to be higher. We will not get a leading current. Okay, so we'll go for the next. Next is relation between the length and the resistance of the cable. We have a formula R is equal to rho L by A. This is the relation. When the length is increased, the resistance of the cable is also increased. R is equal to rho L by A. So what do you mean by R? R is the resistance measured using ohm. And L is the length of the material measured. and that is in meter. A will be a cross-sectional area. Since area it is meter square. And rho is the resistivity of the material. So that is measured in ohm per meter. So this is the relation between length and the resistance of the cable. Next one is relation between power and voltage in the transmission line. Power and voltage in the transmission line. The maximum power handling capability of a transmission line is a function of square of its voltage. So what does it mean is, how a maximum power transfer in the transmission. I want to transfer maximum of power. The loss should be less. Maximum of power should be transmitted in the transmission line. So what is the formula is, P max is equal to V square by X into sine of angle. So what is this V square? Square of its voltage. When the voltage is increased, the power is transferred maximum. And what is X? X is the reactance. When the reactance is increased, power is getting reduced. That is inversely proportional. Reactance and power is inversely proportional. Then what are the concepts we can do to increase the power transfer? We can make a series of capacitance. We can make a bundled conductors. We can make paralleling of transmission line. In these cases, the reactance will get reduced. When the reactance is reduced, the power transmission will get increased. So that's what is said in this relation between power and voltage in the transmission line. And second, I will repeat, I want to transfer the maximum of power in the transmission line. What are the parameters I must check? So maximum power transfer is equal to V square by X into sine of angle. So angle is 90 degree. Okay, that will be better one. So what should be done? The square of its voltage. When the voltage is raised, when the sending end voltage is raised, the power transfer will be more. When the reactance is reduced, the power transfer will be more. How to reduce the reactance? Paralleling of the transmission line, bundling of the conductors, and we can put the series capacitance also. So these are the ways how we are going to transfer the power, maximum of the power in the transmission line. So most probably the overhead transmission lines are made up of aluminum cable steel reinforced, ACSR. So this is the material they are using. So this is made up of aluminum cable steel reinforced, ACSR. We'll go for next. Voltage regulation. So voltage regulation for any machine or any transmission line, it is given that Vs minus Vr divided by Vr into 100. The difference between the sending voltage and the receiving voltage divided by the receiving voltage into 100. So what should be the voltage regulation? The voltage regulation should be less than percentage of 2. It should be less than 2%. Then it is a good voltage regulation. Our sending voltage and receiving voltage should be more or less equal. Then only we can say that the losses are less. So if it is equal, it will become 0. So our voltage regulation will be very minimum. If voltage regulation is going to be higher, many losses are there. So this is the equation for voltage regulation. Vs minus Vr divided by Vr into 100. The next is corona effect. What do you mean by corona effect in the transmission line? Sometimes in the humid environment, when you walk across the transmission line, you can hear some hissing noise. And we can also visually see violet luminous around the conductors. Hissing noise and the violet luminous around the conductor. What does it? It is corona effect. And how this corona effect is produced and what is its effect? The corona effect will drop the voltage, will make lot of energy losses, and it will release the ozone gas. So these things are happening because of this corona effect. And how it is happening is, So the conductor will be surrounded with the air, right? So the air will be acting like a dielectric medium, or it will be like insulating medium. So when the air is acting like a dielectric medium, we cannot say that 100% it is like that. Some free electrons and ions will be moving in the air. Free ions will be moving in the air. So this will make collide with each other. So when this making collide with each other, the conductor is carrying a current. So this will make some magnetic field intensity. And this will increase the potential gradient. When the potential gradient is increased, it will make the current to go across the conductors. And the potential gradient is increased. And that will make the air to get ionized. And at one stage, it will go for the breakdown also. Because of the movement of free ions, it will collide each other and it will go for breakdown also. When it is breaking down, if it is more than 30 kV per centimeter, it will make a arcing. A flash can also be seen. Can make a arcing also. So all due to very high voltage. So this is corona effect. So this will make some voltage drops. This will make energy losses, and this is also releasing ozone gases to the environment, which is very harmful. This is what the corona effect in the transmission line. So we can see from this picture, we can see that violet color luminous all is what the air is acting like an ionization. The air is starting to become like a conductor. Current passes across the conductor. So it is also act like a medium of current carrying conductor. So this is what happening because of the high magnetic field and potential gradient difference is produced here. We'll go for the next slide. Next is skin effect. So the skin effect is also one form of effect in higher frequencies. In higher frequencies, in ultra high frequency, UHF radio frequencies, these type of things, this type of skin effect is found. So what is this actually? So skin effect, actually in the conductor, we have concentric cylinders. We have the inner core, center core, and also we have the outer surface. So what is happening? When the current is carried inside the center core, the current carrying conductor, okay? So the current carrying conductor is taking the current now. So in this condition, a magnetic field is produced. So this magnetic flux, so this will change as a flux, no? So this magnetic flux will induce an EMF. An EMF is induced in the conductor. This EMF is called as a back EMF, or we can say it is an unwanted EMF. It's a counter EMF. EMF is not required, but it is produced. Due to the current carrying conductor, it is produced. Because of the magnetic field and flux, it is produced now. So now, what is Lenz's law? It opposes the cause of producing it. EMF is produced, and what is the cause? Cause is the magnetic flux. So now it is going to oppose the magnetic flux, which is present in the center of the core. It starts opposing. So what will happen? The current will be non-uniformly distributed, and the electric current will start flowing in the surface of the conductor. It will not be passing inside the center of the core. It will pass along the surface of the conductor. It is non-uniformly distributed. Current is wasted. And skin effect. So what is happening when it is flowing in the surface of the conductor? It ruptures the conductor, it ruptures the insulating system, and the skin of the cable is getting damaged. That is called skin effect. So the factors which is affecting the skin effect, frequency. Because of very high frequency, this type of problem is coming. Because of very high frequency, this type of problem rises. And how to reduce it is, in order, we can use copper loops with the silver platings. copper loops with the silver platings are used in ultra high frequency transmissions. So where this type of effect is reduced. Next is diameter. It increases with the increase in diameter of the conductor. If the diameter of the conductor is increased, current cannot pass through only through the center because opposition of back EMF is there. So it will be unevenly distributed. It will be on the surface of the conductor. The shape of the conductor, how the conductor is shaped. So if it is a cylindrical thing, then the center core, outer core, these things are formed. So everything is depending upon the shape of the conductor also and type of the material, what type of material we are using. So the skin effect increases with increase in the permeability of the material. So to formation of this magnetic field, because of this system, skin effect is produced. And we can overcome it by using copper loops with the silver platings. Next, Ferrara effect. So what is Ferrara effect is, receiving voltage is more than the sending voltage. That is called as Ferrara effect. So we'll just see the first paragraph. The effect in which the voltage at the receiving end of the transmission line is more than the sending voltage is known as the Ferrara effect. Such type of effect mainly occurs because of light load or open circuit at the receiving end. In the receiving end, if we does not have any load or if the circuit is open, then the receiving voltage will be very high. And as we know, it will happen in the long transmission also. Due to the capacitance in the cable, it will happen in the long transmission. This effect will happen in the long transmission also. So what will happen if the voltage is raised? You are getting more voltage. But what will happen if the voltage is raised? Our equipment is designed for certain ratings of voltage. If the voltage is raised, it will start burning. So it burns the equipment, it burns the load. So this should be also controlled by using the shunt reactors at the receiving end of the line. So we have to place some shunt reactors at the receiving end of the lines, which is very important. Voltage is increased, receiving end, we are getting more voltage. Voltage is increased, but what will happen? Our ratings of the equipment is different. If you give this type of voltage fluctuation or very high voltage, it will damage the equipment. So we have to shunt some reactors at the receiving end. That is the solution for this Ferrara effect. At last, we are going to see about the transpose in the transmission line. So what is the transpose in the transmission line? Transmission line are transposed because to prevent the interference with the neighboring telephone lines, to balance the voltage drop, to reduce the unbalance of the current and voltage. Transposition in the transmission line is a technique used to restore some of the electrical voltage drop and current balance of the transmission line system. That is when the conductor of a three-phase line are not spaced equilaterally. So the three-phase line, all the lines should be spaced equilaterally. If they are not spaced equilaterally, then the flux linkages and inductance in each phase will not be same. What is the flux produced in each phase and what is the inductance produced will be differ. So this difference will only make an unbalance in the circuit, unbalanced current, unbalanced voltage drops. This is the problem we get in the transmission line because in the three-phase mainly. So this three-phase is not spaced equilaterally. That is the reason of transposing the transmission line. So what they are going to do? They will exchange the position of the conductor at the regular interval of the time. We have to check the line. We have to exchange the position. We have to see whether it is spaced properly, equilaterally. so that the circuit will be balanced, uneven current can be avoided, and we can get a good transmission. So the transposing of the transmission line is also a one form of topic. So that's the basics of your power system transmission line. More topics are there. Electrical is very vast. We have taken only some of the common important topics. So thank you for listening.